Hello mathematicians, we're now going to have a look at the theory of the discriminant. But much of this is just about pulling together ideas that you've already encountered. So if we go really quickly through here, we know what the discriminant is. It's b squared minus 4ac. We know that if the discriminant is negative, the implication is that there are no zeros on our parabola, which means that it doesn't cut the x-axis. If the discriminant equals 0, then there is only one zero or one root. So that occurs at x equals minus b on 2a, the axis of symmetry, and it means that the parabola comes and touches the x-axis at one point only. And if the discriminant is greater than 0, there are two zeros, or two places where the parabola cuts the x-axis, and they may be nice numbers, which would happen if the discriminant is a perfect square. And nice numbers is not very technical. Perfect squares would be better. And they may be surds if the discriminant is irrational. So we're just going to build on that now to say if the discriminant is less than zeros, then again, something we already know, that can't be solved, the parabola doesn't cut the axis. So depending on the value for a, if a is positive, our parabola must be concave up and doesn't come below the axis. If a is negative, our parabola must be concave down and doesn't come up above the axis. If the discriminant is 0, then if a is positive, we come down and we touch the axis at the axis of symmetry, and if it's negative, that's meant to be just touching the axis at the axis of symmetry, and these roots are called double roots, and it happens when we've got a perfect square. And finally, a repeat of what I said above, that if the discriminant is greater than 0, there are two zeros in there. Let's have a look at these examples. So we have the discriminant is b squared, which is minus 4 squared, minus 4ac, so 4 times 1 times 3, which is 12, which equals 4. So our discriminant is positive, so we'll have two roots. It's also a perfect square, so those two roots will be rational. For our next one, the discriminant is b squared, which is 9 minus 4 times 1 times 4, which is 16. So it's less than 0, and therefore there are no roots, no real roots. For this one here, and so the parabola doesn't cut the axis. For this one here, the discriminant is b squared, which is minus 3 squared, minus 4 times 2 times 8, so 4 2s are 8, 8 5s are 40, and again, that's less than 0, so no real roots. For this example, for what values of lambda does this particular quadratic equation have equal roots? So equal roots means that we've got the discriminant equal to 0. We've got two identical roots, or a double root. So part of this topic is about the terminology as well. So what do we need if we're going to have the discriminant equal to 0? Well, if we get our expression for the discriminant, it's b squared, which is minus lambda plus 5, all squared, minus 4ac, so that's minus 36, and we want that to actually equal 0. So if we work on this now, then we're going to have so the negative is gone, so lambda squared plus 10 lambda, I don't know what's happening to my pen, plus 25 minus 36 equals 0. So that will give us lambda squared plus 10 lambda minus 11 equals 0. If I factorise that, that will give us minus 10 and minus 1. This pen is annoying. So lambda equals 1 or 10. So either of those values will give us a quadratic which has equal roots. And for part B, if it's going to have no roots, then again we want our discriminant which we've already worked out here, to be less than or equal to 0. So if we jump down, no point redoing all of this, if I jump down to this spot, that gives me, well, go further, lambda minus 10, lambda minus 11, minus 1, sorry, to be less than 0. Now I can look at this thing here in turn, which is a quadratic in terms of lambda, and it's concave up, and it's cutting at 1 and 10. So what are the lambda values which create the area where this parabola is less than 0? Then the lambda values between 1 and 10. So my solution is 1 less than lambda less than 10. I'll go and see if I can fix this pen, and you can do 8F.